So yesterday, I think there's a few very distinguished speakers talked about 5G, and talked about the also the data kind of exponentially growth, and whether it's going to be continue. I'm not going to repeat that part, but I'm going to talk more on our vision in 2020. So in our view, in 2020, there will be the three 1,000 times. The first 1,000 times is the increase of throughput. Obviously, it comes from the need from the traffic, right? The internet growth, traffic growth, 1,000 times for mobile communication. And the second 1,000 times is the spectrum increase. So we see there's a need to dramatically increase the spectrum for mobile communication, for the wireless communication in the future. The third 1,000 time is the 1,000 time energy reduction. So I think Dr. Yi and many other speakers talked about yesterday. There's a great need to reduce the power consumption in the mobile networks. So let me give a little bit more detail on this. So what do we mean by 1,000 times throughput increase? So today, the micro station, we know its typical capacity is 300 Mbps, and the terminal, typically the capacity in the cell is 10 Mbps. So we see there's a need to increase that for future in 5G. So terminal will have 10 gig BPS. And also for the macro station, is going to be 50 gig BPS, and for micro station is going to 100 gig. That's a throughput part. And the spectrum part, we know the typical LTE, the cellular band is 20 meg. And we see there's a need to increase that for future 5G. The cellular band will become 500 to 1 gig hertz for the cellular band. And in total for 5G, including the 30 gig and the 20 gig band, it could become a 10 gigahertz spectrum need. And that's the spectrum side. And for energy, we know that currently the RAN, the typical the energy efficiency is about per joule is about 0.2 megabit. And we see that, and from also many publications, including the result we see from the Green Touch Research Consortium. In the future, it's possible, and there's a need also to reduce the energy efficiency, increase energy efficiency to the 0.2 gigabit per joule. So that's also 1,000 times increase for the energy efficiency. So that's three 1,000 times. I'm going to talk more on those and in the following of this presentation. Then we see what does it mean to the end user, to these three 1,000 times. So that's the here this slide show. That's the basically means what's for end user. Basically, this is like a 10 gigabit word for end user. So what does it mean? It's a true visual and virtual reality experience. So we talked about a lot yesterday. So I'm not going to repeat those applications. So for 5G, so this 1,000 time, so it means the massive capacity for end user. So as you can see, from macro side, obviously we cannot reach that. So we have to utilize other technology as well. So including the local network. So for example, the Pico and also the maybe Wi-Fi, and we reach 10 gig BPS in the local area. But for the for the bigger coverage area, we should be able to achieve 1 gig bps to 4 gig bps. That's for the end user to have massive capacity. So to the user experience, so we have this super high speed network. So it means you have zero distance to the future internet. You have zero distance to the world. Now we talk about the connectivity. Yesterday we also talked about the machine-to-machine communication. What's the future of it? And there's many numbers here. So as we can see, there's going to be many more nodes, computers, and the vehicle telemetric, resident and commercial buildings, and also industrial automation, which will link to the machine-to-machine communication we talked about yesterday. And it's obviously there's a lot more to come. And 5G, in order to achieve this, in order to support this, it has to support the massive connectivity. So we're talking about this 2020 thing, but for the 2030, we envision there's a need to explore 1 trillion things. Well, obviously, we cannot avoid a spectrum when we talk about cellular or mobile communication. 5G, in our vision, is for all spectrum access. So we think there's a need for a single and unified interface. So it includes the cellular band and this 5 gigahertz, 20 gigahertz to 50, 60, and to 90. So obviously it includes some band which is unlicensed, and we see there's a need to build a interface which include all these different bands, so that we can have the unified network. So I talk about the 3 1,000 times, and to the usage applications. So yesterday we also talked about what's the killer application, but now nobody is talking about it anymore, I think, because the future internet is going to be the killer application. That's for sure. There's plenty of applications. The question is whether or not we can support it. There's no lack of applications in the future. So how we support it, whether we can support it, that's the question. So here list the 4 numbers. I think is for the landscape for 5G wireless. So obviously we talk about this M2M. So this means anytime networking, and also this small radio network include this a lot more cells, and this the spectrum, more spectrum, and also to enable the access to the massive amount of content from the internet. So what does it mean? So those numbers, so many big numbers, it means a lot of things. So if you think about it, it's a 3,500 things will be wirelessly connected for every second in the next 10 years, or in the 10 years time frame from 2020. And also for every second, for 10 years time frame for 5G, there will be 30 nodes will be installed every second. For the current cellular network, obviously we cannot support this. So we need to rethink the architecture and redesign the 5G wireless. Here are the challenges, technical challenges or requirements from what we have talked. There's 5 needs basically. the need for immersive experience. To really realize the user experience we talked about yesterday and also in the past, the virtual reality, and this type of 1 gig bps multi-view ultra high this video. We must have this type of new technology. This is one design challenge. The second design challenge, yesterday I also talked about it. It's a fiber-like user experience. User get used to the fixed access, and they experience the fixed access, the high speed, and then the zero waiting from the fixed access. So for mobile, we also need to provide that kind of user experience. To do that, 5G need to provide 10 gig Mbps. And yesterday, I think Professor Fadweiss talked a lot about new applications on the latency requirement. He pointed out this 1 millisecond. We also vision that there's a need to have 1 millisecond latency for the new 5G design. So we call it the need for zero latency experience. Another need is the switching time experience. Obviously, for GSM, it's the second level, and so 3G is 5 milliseconds, and to 5G, we think it need to be 10 millisecond level. Obviously, there's a lot of rethink, re-architect, and redesign is needed. And there's also the need for always on, which means this connectivity number will be super high, and we talked about that in the past few slides. I'm not going to repeat that. So 1 billion things to connect, and a lot of application, and 5 billion people, it will be in the network. Well, we touched a little bit on the spectrum, and with that, there's going to be super need to increase the spectrum from regulation point of view. And IMT, for every 8 years, we know that every 8 years it's going to have a spectrum allocation conference for WAC 92 and the WAC 2000. And also, this just passed is WAC 2007. They also located the spectrum for the mobile business, for mobile industry. To that said, about 300 megahertz spectrum has been located, and this future spectrum location, very likely for mobile, it's very likely will be concentrated in the 3 gigahertz above, and also below 1 gigahertz. And there's a lot of discussion on spectrum, and appears to me we think, and many people in the room also think that there's a need to have at least additional 500 megahertz new spectrum by 2020. So I think today we're going to have a panel on the spectrum side. I'm not going to talk too much on that for today. So then I go to a little bit more on the technical side. What do we mean by 1,000 times capacity? So here we mean it's going to be 1,000 times faster than LTE. Here it shows a roadmap. A roadmap is not necessarily the roadmap. So for high capacity, it's a rough number and some calculation. So we think to achieve the 1,000 times faster than LTE, they need to have 4 times spectrum, either from new allocation or from refarming. let's assume we have 4 times spectrum. And also from the ultra dense small cell, basically we have more cells and smaller cells. This will give us 10 times for this multiplicity law in order to reach this 1,000 times. And more importantly, there's a new air interface design, and also for the RAN new architecture. So we think there's need for a spectrum efficiency gain in order to reach this. There's some discussion on what kind of technology it should be included. So we put this 4 by 10 by 25. So basically a rough number. It give us this 1,000 times faster than LTE. Well, with this said, by 2020, we will have 1,000 times faster than LTE. But if we think even beyond 2030, so there's a need to explore a lot more, maybe 1 million times capacity for 2030. So, but that's not something we're going to talk for today. While we talk about the spectrum, we talk about this capacity, and also there's a clear 1,000 time goal for 5G design. We think 5G will be 1,000 times greener. To achieve this, there's a lot of discussion in the past few years, and Dr. Yi talked about that yesterday. I'm not going to repeat those. So this figure just shows there's different level of solutions and research projects. So we believe it's highly possible we reach this 1,000 times greener goal for 5G. So with this in mind, we can see maybe we cannot completely bring down this curve in order to, we talked about this also yesterday, in order to make the operator profitable, we need to have this cost curve down, right? Obviously, this green technology will have that. So to have this 5G, a lot greener 5G, we should be able to help on this part. This is something in our mind for the 5G wireless network. So for a user, it's 10 giga user experience, 1,000 times faster. So as you can see, there's going to be a lot of new devices. So we can see this iPhone, iPad, and these things will bring capacity, and also a lot of new things we talk about for machine-to-machine also. So for this type of for user, maybe the machine-to-machine communication, we don't need 10 Gbps connection, but for many of the devices, end user will expect this level of capacity or throughput in order to reach their user experience expectation. Well, I think this is also a topic from yesterday. We also talked about that. CMCC has talked about this CRAN, and obviously there's some different view on whether CRAN is needed, but I'm not going to get into that. So what we want to talk about here is that we do see CRAN has a important role in the future fifth generation wireless network. So what do we mean by that? So what we mean, edge interface will be software designed platform. So it's going to be the decouple from software from hardware, and also the decouple of spectrum, which we have as industry have worked on that for many years. So SDR. There's also openness So basically, we mean using open flow lag control for Mac state machine. So that's something we are doing inside my company. The other aspect for this Cloud Run-based radio access network also mean the delayering. So the TCP IP obviously is not designed for radio and mobility. We are working on that to decouple those layering and also to figure out what's the next this IP technology to support this. There's a lot of new terms and also technology. For example, the radio, we call it radio computing architecture. In order to support the super stringent latency requirement, there's a need to design the new computing architecture. This hyper transceiver architecture is also a Huawei innovation. With this, we can reach the cell capacity by 2 times, and also the cell edge throughput increased by 4 times. This can only be enabled by the Cloud Run architecture. Huawei has conducted the world's first LTE over cloud at Shanghai. We worked with Shanghai Jiao Tong University, set up a field trial. In that field trial, we achieved the industry first. The cell capacity increased 2 times, and the cell edge throughput 4 times, and also the timing accuracy, and also this new technology design for a CPRI compression at that level. So if you got a chance, and then we invite you to that field trial. So we call this a hyper transceiver architecture. Is enabled by the C-RAN architecture. It's ultra node as another important piece of technology in the whole picture. We have published this, I think, in Barcelona this year to reach the 50 gigabps per site. I'm not getting too much about it. It's a concept. It's a cell concept. So, okay. I'm not sure how much time is still left. So, obviously, 5G is in the horizon. Likely a lot is going to come. So here's a kind of a big picture on that. So we can see that there's a target. I think that's the goal for the community to deliver this technology in order to achieve the support for these new applications. Well, we have that side. Obviously, there's a lot of barriers. One important thing is that the spectrum. We cannot do much if there's no spectrum, new spectrum allocation. So, in order to get this spectrum, the one thing obviously saying is that to do that, reform this 2G, 3G spectrum. But that's not enough. So we have to work as a community to urge the regulation to allocate more spectrum for mobile business, for mobile industry. This is one of the barriers we see so far. And then another barrier to achieve this 5G vision is there need more sites. So there's 10 times more sites for small cell. We know it's very challenging for carriers to get the sites, especially for the new sites. So how we do that? How do we overcome that barrier? Remains unknown, but there's a need for us to work together to figure it out. And another thing is to densify the microcell. That's something maybe slightly easier. The third thing is obviously also super important. It's a new technology breakthrough. We talked a lot in the last couple of years on the new technology. What is going to be the key aspect of 5G? There's a lot of discussion, but we still need new breakthrough in academic research. So there's a lot of work to be done, and there's a lot of potential. Well, many people in this room are very familiar to this. I'm not going to talk too much. So it's a good thing that the whole industry is working on this, and there's we have clearly the envision the similar view. I think this slide also kind of familiar to many people. So 5G is coming. Thank you a lot. Thanks a lot.
Yeah, thank you very much. We have time for a number of questions here. So Mikko was first.
Also referring to unlicensed spectrum. So how do you see the role of that in this small spectrum?
Well, for unlicensed, and when we talk about this 5G spectrum 1,000 times, obviously there's a lot of regulation related issue. So unlicensed spectrum is something we think. Maybe for Wi-Fi and this type of thing, we may utilize for our purpose as well. I'm not sure whether I answered your question, but
which other purposes than Wi-Fi do you see for unlicensed?
Yeah. And maybe also for Wi-Fi, we can for this. New Wi-Fi technology also is part of the whole picture to support the this 10 gig per person.
Yeah, thank you. Laurie had a question here as well.
Okay, thanks. So you spoke about 10 times more sites for small cells. So can you a little bit clarify that? Is this mainly for outdoor small cells, or do you include indoor small cells? Because I think that you need a lot more indoor small cells than just 10 times. So can you?
When we talk about this, means sites, many outdoors, and also, yeah.
Yeah, and Kevin over there.
I was curious about your ultra node. I mean, we just saw that Samsung announced a 5G macro site at 28 gigahertz there. What frequency do you operate that?
The cellular band.
Cellular band?
Yes.
Is it a smart antenna technology or?
Yes.
So Eric, the final question.
Thank you. Thank you very much for the interesting presentation. I was somewhat fascinated by your view here on how you achieve this kind of 1,000 times capacity, which at least to me was a little bit opposite to what you typically hear, because you talked about, as Lauri was point, 10 times more densification, and then like 25 times higher spectral efficiency. And in most presentations you see around the world, people are rather pessimistic about like the potential for the basic spectral efficiency. They talk perhaps about a factor of 2.5 or 3, which is also the typical number we've had for each generation, and perhaps then you need a factor of 100 in densification. Have you any idea how you would reach this kind of, in my view, rather large step of 25 times better basic spectral efficiency?
Well, I think this will give us, if we think about the future, the antenna number from base station and also terminal will increase significantly. I think people are starting to talk about that, and that's definitely one direction to achieve a lot higher spectrum efficiency. There's also a lot of other works, and like the new waveform. I think that people define this in the Matthews, I believe. So people we believe that this number is achievable, and there are some technology we can discuss offline.
To a large extent, the kind of massive antenna configurations.
That's one of the technologies, yes.
So, thanks again.
Thank you.